The construction of a real-time visualization, as easy as possible to do, is always going to be something that we strive for, with one way in which we can help do this being the use of construction scripts in our blueprints that allow us to set up important blueprint information when our actor is created, rather than having to do it manually after the fact. To start utilizing the construction script for our automatic door, we will want to make sure that our automatic door blueprint is open, and then also make sure that we are viewing the construction script graph. If it is not available as a tab, we can double-click on its name inside the Functions rollout of the My Blueprint tab so as to open it up. What we are wanting to do now is set up information that is unique to this actor, specifically the position of the left and right doors in relation to the frame mesh and where, ultimately, the blueprint actor gets placed in the level. Rather than set this up manually each and every time we place our actor in the scene though, we can simply use the construction script, as each blueprint class has just a single construction script that executes on creation, which is why it makes sense to set up our door starting locations when we create the blueprint, as we can then use this information later on. To have our construction script function properly, we will need to store the door's starting location, which we will do via variables. To create one in the Variables section of the My Blueprint tab, let's click the Add Variable button. Give this a descriptive name, so door r_start, and then press Enter. Over in the Details tab, we will also want to make sure that the variable type is set to float, after which we can click the Compile button. Now, variables can hold lots of different types of information, from full references to actors in a scene, to arrays, or, in our case, float values. We need to use float values here because the nodes that we will want to work with later will need a float input in order to both tell the blueprint where the doors are currently placed and where they need to be moved to. Having just a single door's position, though, is obviously only half of the job, and so we need to store the same for the other door as well. After clicking again on the Add Variables button, we can call this one door L_start, and then press Enter. If needed, we can also make sure that this is a float variable type as well. Now, I'm using two variables because there are, obviously, two doors that require unique starting positions. We could use some clever maths to figure out the location of the doors based on the scale of the frame and the doors combined, but in this instance, simply storing each location in a variable is quicker and easier for both newer Blueprint users and for myself. We have the variables, but we also need to tell the construction script which static mesh or meshes it is meant to be looking at in order to get a location value. Let's drag the AutoDoor_R component onto the graph then, after which we can click and drag on its output, and then release the mouse anywhere on the graph in order to gain access to a list of nodes that we can add. Let's type getRelativeT, and then select the getRelativeTransform node that appears in the list. Whenever we drag from the Components section of our UI onto the graph, we are actually making a reference to that component. In our case, we now have a reference in the blueprint to the AutoDoor_R mesh. This in turn allows us to use the getRelativeTransform node, and so get the transformation data from that specific static mesh. We are using this as opposed to the getWorldTransformation option because should we use that and then place our door at an odd angle in the scene, the doors won't slide open along the proper axis. Let's take a look next at how we can actually drill down into our node outputs in order to gain access to some of the more specific information that it contains. After right-clicking on the return value of the node then, let's choose the Split Structure Pin option from the list, and then right-click again, this time on the return value location output, and choose the Split Structure Pin option a second time. We are splitting the pin here so that we can gain access to each of the transforms separately, and then splitting again so that we can choose the specific axis of a specific transform, be that X, Y, or Z. As our automatic doors are only ever going to slide left and right, splitting the pin means that we can easily gain access to the correct axis and only change that one value. Time to put our variables to use now. And so let's click and drag our door r_start variable from the My Blueprint tab, and then place it onto the graph. We will choose the set option when prompted to make a choice, and then drag from the construction script node's output and pipe it into the variable node's set input. We are choosing to set our variable when the actor is constructed because we will always need the start position of the mesh, as the construction script is, as already noted, designed to execute upon creation of the blueprint object, and again whenever that object is updated in some way. This means that whenever we move the actor to a new location, the script runs, the variable is updated, and so we always have the correct starting point for our door slide calculations. Dragging from the return value location y output now, we can pipe this into the door r_start set node's float value input. We can see from the viewport tab now, if we select a door with the move tool engaged via the W key, that it is the y-axis that we want to change in order to get the door to open and close correctly. And so, it is the current y position that we will want to store in this variable. Each time our blueprint is constructed now, it will look at the AutoDoor rStatic mesh, grab its current world location, and then set our variable to that value. Just as before though, all we have set up here is a single door, and so let's drag the AutoDoor_L component onto the graph, right-click on the Get Relative Transform node, and then choose the Duplicate option, after which we can move it into place and pipe the AutoDoor_L actor into its target input. Clicking and dragging on the door_L_start variable, let us select Set from the list that appears once we release our mouse button over the graph, and then pipe the output of the duplicated Get Relative Transform node's return value location y into the set node's float value input. As already discussed, we need a value for both the left and right doors for this effect to work properly, and so have performed the same procedure on the opposite door component. And even though each component actually references the same static mesh file, this will work just as we want. We are almost done here, with just one more action to perform, and so let's drag from our door rStart variable set node output, and pipe that into the door_L start set node's execution input, which just makes sure that the left door variable gets stored right after the construction script has stored the right door variable. And there we have it. We have told Unreal what to do each time this actor is created now. So, we are storing the y-axis for the two static mesh components in two different variables that we will eventually use to create the start and end points for our automatic door animations. Again, if this is not 100% clear at this point, don't worry, as we will be seeing it all in action in a little while.